好，那我们接下来的讲者，他是Episodes 的工程师，那他对于 data science NLP machine learning 是有长期的研究。那他是从那个印度孟买飞过来的。那我们接下来他的题目是Serverless 的架构的介绍哈。那我们掌声欢迎他。
Hello. Uh, okay, so today the talk would be about understanding what exactly serverless architecture is and what the hype behind it. So the talk would be basically I've divided the talk into two parts. The first part would be understanding in and outs about what a serverless system is, how it works, and why does it work exactly how it works. And the second part would be the lessons learned and the pitfalls we faced while we were building serverless architecture at our place, and how do we scale serverless architectures up, etc. So I just wanted to ask, how many of you heard about serverless architecture before, the word serverless and everything? Okay. How many of you worked on serverless architecture before? Like, do you have any experience with either AWS Lambda, Azure? Okay. So I would be using AWS Lambda for the demonstration. So if you guys have AWS accounts, probably you can follow along, or else it's okay. So I guess I was already introduced, but I didn't quite understand. I don't understand Chinese, so this is my introduction. I work on DevOps and machine learning full time at Episodes in India. Uh, in the free time, I contribute to data science and machine learning libraries in Python, Julia, and Go. Uh, Also, I moderate the DevOps site of Stack Overflow. So, let's start with a basic understanding of what serverless is. Okay, so if I'm a beginner in serverless architectures, etc., specifically I'll go to Wikipedia and see what exactly serverless means. So Wikipedia says this: serverless computing, also known as function as a service, is a cloud computing code execution model in which the cloud provider fully manages starting and stopping of a functions container platform as a service. How many of you really understood this term, this sentence? At least I wouldn't if I'm a starter. So I'll further break this down uh, with each phrase. I'll explain you what exactly it means, and also you guys can see how exactly it works in production, right? uh, so the example which I will be showing you would be a very basic one. How many of you know about S3 buckets, or should I explain it? Just raise your hands. How many of you know S3 buckets? Okay, it will be better. How many of you don't know what S3 buckets are? Please raise your hands, because if I don't explain that to you, it will be very difficult for you guys going ahead. All of you know. Okay, okay. S3 buckets is one of the service of AWS, which the basic concept is there is a bucket, and inside those buckets you can store files, folders, etc. As simple as that. So I want to move uh, a file from one bucket to another bucket as soon as it got uploaded into the first bucket without me doing anything. It should happen automatically. Okay, so we'll be working on that example. Depending on that, I'll be explaining you the slides next. Okay, now going back to the definition, let's understand what function as a service is. Okay, every serverless service has a something called a function. which is executed whenever it gets started. Okay, the function will be triggered by something. Like for example, in our example, it is triggered whenever a file is uploaded to the first bucket. Okay, uh, this is the AWS console. This is an example function. So these would be some libraries. What I'm doing is, whenever a file is being uploaded to a specific bucket, I'm hashing the name of the file and putting it to a new bucket. As simple as that. So I've used base64 for that. Okay. So I'll be putting it to the destination bucket. Destination bucket name is PyCon TWB2, and copying it from the source. Okay. All right. Now let's understand the part of managers starting and stopping of a function, right? So what exactly the triggers are here? If we go to the console again and see the trigger for this, the trigger here is an S3 bucket named PyCon Taiwan B1, which is the first bucket, and it is triggering that function whenever there is an object created. Are we clear here, or are there any doubts? Because this is a live demo, so I'll be you guys can ask me doubts after every step. Don't be shy. All right, so you can add more triggers if you want. So the function starts whenever the trigger is activated. And when is the trigger activated? When there is a new file in the bucket 1. Okay, and when is the function stopped? The function is stopped whenever you return something. You can add a small return true or whatever, and then it gets stopped. How many of you know containers? You guys know containers, right? Okay. So behind the hood, what? Let me give a small demo. This is bucket 1. Okay. This is bucket 2. So you have just seen what happened, right? I've uploaded the file to bucket 1. The function has got triggered, and the functions, what my function does is it hashes the name of the file and puts it to a new bucket, and this is the same file with a hash name. Any doubts here? No doubts. Cool. What happened behind the hood is, whenever the function got triggered, AWS or whatever your cloud is, it can be G Cloud, it can be Microsoft Azure, depending on that. Uh, there is a container being created, the code being executed in that container, and then after the task is completed, the container is destroyed. Everything happens behind the hood. You don't need to do it manually. It is taken entirely, it's taken care entirely by the cloud, right? So we are not maintaining any servers here, if you have observed properly. Also, as I've just explained, creating of the container, provisioning it, and the code running inside that, everything is taken care behind the hood and automatically. This can be, this is a very basic demo which I'm telling. Like for example, there can be one more real world example. What I can say is, I have flew flight from Mumbai to Taipei. Okay, so whenever Google detects my location, whenever it detects that there is a change of location, they can write a function saying that, hi, these are the new places around you in Taipei. That can be used as a trigger. Change of location can be used as a trigger, and then notification can be used written as a function inside the code. So you can do a lot of cool things using serverless services. Also, with all the free time you get now, not maintaining servers, you can ogle about how beautiful your Linux logs are. Also, the advantages of serverless computing is, firstly, you don't need to maintain servers. Maintaining servers is a lot of headache in production. Like for example, what if a server goes down? Your entire service goes down, right? And I don't need to hire one more guy in my team or one more girl in my team to maintain those servers. They can work on much more productive things like writing cool machine learning algorithms, making really good front end dashboards, etc. And it saves a lot of cost. Imagine an entire server running 24/7 for this particular task, right? Now the server behind AWS cloud runs for only a couple of seconds versus a server running 24/7. That's like massive amount of money saved. I'll give you a bit of a different perspective here. What if you're doing a really complex deep learning task? Everybody know what deep learning is, right? No, don't kid yourself. Nobody knows what deep learning is. Okay. For example, I'm running some LSTM task or something. Like whenever I get a file in my database, I want to run an LSTM code and detect some keywords and put them into a new database, right? So deep learning doesn't happen on normal servers. They require GPUs. They are like monstrous servers, right? Imagine a GPU instance running 24/7. How many DevOps guys in the house? Backend devs? Yeah, they would know the pain of handling GPU servers running 24/7. And here, probably it will be for just for 1 hour or 2 hours, depending on how long the LSTM task takes, how long the deep learning task takes. Having said that, there is a very big list of disadvantages which serverless computing has. And later, I'll be explaining you how we worked around those and possible solutions you can work around while you are building serverless architecture. So till here, are all of you guys clear about what I've talked till now, the advantages, how it worked, etc.? Please don't feel shy to ask doubts. Okay, assuming that all of you guys are clear. The first disadvantage is functions are allowed to run for a very limited amount of time. In AWS, the time is 5 minutes. A function cannot run for more than 5 minutes. It gets killed automatically. So now you guys are thinking that why did this fellow talk about deep learning? Deep learning tasks take obviously more than 5 minutes, right? So I'll come to that later. So here, let's show us some slide demo. Then we go to the console, go to configuration, go on settings. That's the timeout. 5 minutes. If you want to check it for yourself, probably copy some deep learning task or something, put it there, and once it finishes time 5 minutes, it gives you a timeout error and it shuts down. That sucks, right? It sucks. Also, there is no control in where the container is running. The container which is being spawned by the cloud, there is no control on that. Like which OS is it spawning? Which OS does that container use? And where is it being spawned? Is it being spawned in a virtual private cloud? Is it being spawned in a subnet? How many of you know what is a virtual private cloud? Or do you guys want me to explain it? Okay. Virtual private cloud is a part of the cloud which is dedicated and only to you, and only you can access that. Okay, which means that working in a virtual private cloud gives us more security. As simple as that. But here, what Lambda does is it runs in its own virtual private cloud, not in ours. So there is no control over security. What if the document which it is running some tasks on, what if it's a sensitive document? What if they are health documents? I work in a healthcare company, so the data should be encrypted at rest and also at motion. It should not come out of the country which it belongs to. So running in its own VPC doesn't solve our purpose, right? And having its own OS. Amazon uses Amazon Linux for its containers. So you can't just go about writing your code in Ubuntu, assuming Ubuntu or whatever you use. And yeah, monitoring serverless applications is really difficult. And I'll be speaking about horror stories a bit later, uh, which are distributed systems. How many of you know distributed systems? What they are? Okay, they're like fresh hell of computer science. Distributed systems, nothing much. And I have told you, heavy workloads cannot be run. What if you wanted to do fully serverless machine learning, fully serverless deep learning? That is not possible because of the time limit, as well as I've told you, as we don't have control over the OS, we don't have control over the VPC. So the next half of this talk from here would be about how we worked over those disadvantages, and how we built a serverless system from scratch, which includes distributed systems, that same hell of computer science which I'm talking about, uh, and also the advantages which we have reaped from using serverless architectures. Till here, any doubts? I'll wait this time because we have covered a lot of portion, and I'd really love it if you have any doubts. No doubts? Okay. Expectations of the from the project which we have built. We wanted to build a completely serverless end-to-end data pipeline. What I meant by end-to-end data pipeline, I got the data from somewhere into my own database or into my own S3 bucket. Uh, I have to do some transformations on the data cleaning, data transformations, whatever you call it. Next, I wanted to do a first level of machine learning on that. And then I wanted to do a second level of machine learning, which is deep learning. And then I wanted to use the results of deep learning, make it presentable, and then push it to a new database. This is my entire data pipeline, and I wanted to be it completely serverless, like entirely serverless. I don't want to run servers. I don't want my team, anybody in my team, to sit there and wait for the servers to crash. And the competitions are really, really like they're health documents what we are working on. So health documents range from 1 page to as long as 600 pages. Imagine a deep learning algorithm running on a 600-page document, right? So really deep computations, heavy computations. So the first disadvantage is a limited running time problem. As I've told before, in serverless systems, the container gets killed after 5 minutes. So here I wanted to do deep learning inside the same computing architecture. So the first thing some of my team members asked is, "What the hell is wrong with you?" So, but the idea of serverless is really cool. So how did we solve that? The entire pipeline, as I've explained you, takes at least 1 hour to run, right? That is for 30 files. And our goal is to reach 1 million files. 1 million files, you can do the math, right? For 30 files, it takes 1 hour. For 1 million files, you can do the math. So, and then, so even if it is for 10 files also, clearly the 5 minute limit is not for us. 5 minutes, we are not going anywhere with that 5 minute limit, right? So we have to work around that. How many of you know what Ansible is? Puppet, chef. Okay, you are a DevOps guy. Okay. Ansible is a basic orchestration tool. Like for example, you're running Ansible. Ansible can be run for creating servers automatically, doing some tasks inside them. And how we use the Ansible here is, there is a container which gets created whenever the function gets activated, right? So what we did was, that inside the function, we have asked it to create a new server. Okay, the function's basic job is to create a server. All right, it creates a new server, runs some tasks inside that, like sudo get update, sudo pip install, whatever machine learning libraries I wanted to run, right? And then finally running an Ansible playbook. What the playbook does, it creates more servers. Wow. uh, Here we wanted to do deep learning tasks, and deep learning tasks have to be distributed. Like for example, if there are 30 files, you can't expect a single server to do heavy deep learning tasks on all those 30 files, right? So what if I have million files? That's what I told you. What if I have million files? Do I expect a single server to run for 24 hours for an entire month to complete all the deep learning tasks on those files? No, right? So each 100 files, for every 100 files, there is a server getting spawned. So what if there are 1000 files? There are 10 servers being launched from that particular server, which is being launched by the function. So how it works? Uh, okay. Here we have our function AWS Lambda. Okay. It creates one more server. This acts as the master for Ansible. Okay, Ansible runs inside that. Okay, the first task of Ansible is to check how many files are there in my S3 bucket. Depending on that, create x by 10 by 100. Every 100 files will have a server. So if there are 1000 files, what happens is the function gets triggered, a new server gets created. The first task of Ansible inside that is create 10 servers. There is a master and there are 10 workers, some tasks running on workers, and after all the entire tasks get runs, till then Ansible would be orchestrating the and all of those 10 servers. So from this example you might have thought that, so here I see 11 servers running and this fellow is talking about serverless architectures. What the hell is wrong with him? Right? So Ansible's last task is, after I have completed the entire machine learning on that, those particular files, put it into a final database, kill the worker. After I have completed deep learning on all those 100 files, I have put them back into a final database. The task of the worker is completed. So kill it. So what happens after all the 1000 files gets processed? All the 10 workers which have been launched are killed because they have completed the tasks. But still there is a single server remaining here. What server is that? The server where Ansible is running. It's the master. After all the workers are killed, I have asked the master to do a suicide. It is possible. Uh, you can use AWS CLI to do that. And now, how many servers are left? 0. An entire deep learning task have just happened. There is a distributed architecture which have been spawned, but at the end of the day, I have 0 servers remaining to maintain. That's a dream of every DevOps guy. I don't need to maintain any servers here, right? See, so that's the beauty of serverless computing. And imagine how much money I'm saving here. Imagine how much money I'm saving running GPU instances for just 1 hour versus running them 24/7. So this is what I've told. How many of you know what a NoHub is? Raise of hands, please. How many of you know what NoHub is? If you have Unix systems, you can try any command. Like for example, Python test.py you do. It runs a Python file. Try doing NoHub Python test.py. It will run in the backend. You don't need to wait till the Python file gets executed to run the next command. NoHub makes it possible to run anything, like for example, anything in the background. You don't need to wait. For example, if I do Python test.py, I need to wait till the Python file gets executed, and then only I can press the next command in my Mac or in my Linux system. But doing with NoHub helps execute our task in the background. Okay. Now I've just solved one of the horror, one of the disadvantage, the 5 minutes thing. Next one would be I have no control over the container. What OS is it running on? Where is it running? Because deep learning would obviously involve libraries like TensorFlow, Keras, etc., etc. Right? And I need to be using GPU instances. And Amazon Linux, which is being created by AWS itself, is not a GPU instance. Also, I don't have control on where it is running, whose subnet is it, whose VPC is it. So again, we solve the problems using Ansible. Here, as you have observed, the task of the container which is being spawned by AWS is just creating a new server. So I don't really need to care where the hell is it getting executed, or what OS is it running on, anything. I just need to control where the master is, where my workers are, and what exactly are the OS of my master, OS of my workers, security settings of them, right? Using Ansible, you can create whatever OS server you want, wherever you want, in your own private subnet, in your own private VPC. Same thing works with workers also, the servers which actually touch my files. How many computer science students here? Okay. So yeah, distributed systems are one of the horror stories of computer science, to be very honest. Uh, you might have heard about Kubernetes, Docker Swarm, Zookeeper, Hadoop. All of these are mostly distributed systems, and even the architecture which I have explained you are distributed systems. Nothing but all the systems are distributed and being orchestrated by a master. Okay, it is a very powerful paradigm. You might have realized it with the example which I have just explained. It's a very powerful paradigm, but it comes with its own set of horrors. Like, what if a worker goes down? It has 100 files in that. It is executing 100 files. It is running machine learning algorithms on those 100 files. What if the worker goes down? I have zero control because it's a serverless system, right? I have zero control on the worker. What if it goes down? And if it goes down, I will not be getting those 100 files again. How do I recover from that? What if master goes down? If a master goes down in between, the final task would not be executed. What's the final task? Killing all the workers. So what if a master goes down in a run? How many servers I'm left with? 100 servers. I'm left with 100 servers which are running 24/7. No one can kill them now. You just go manually and kill them. So are you getting what I mean by horrors of distributed systems, right? So and have you guys heard this term called self-healing architectures? Just like serverless architectures, there is this thing called self-healing architectures. uh, so one, this is just an advice. Whenever you guys have to scale up your serverless services to distributed systems, just like this, using this example, make it self-healing. If it is not self-healing, then you might rather not use distributed systems. So if you have built a really great distributed serverless architecture and you have not made it self-healing, then prepare to get fired. And I'm serious. At the end of the day, just like I told you, at the end of the day, if I'm left with 100 GPU instances running round the clock, imagine what my billing would look like at the end of the month. The CFO would be running straight to your room and you will be given a pink slip before you can say self-healing. And then monitoring and logging. For the simple task which I've shown you, putting one file from a bucket to another bucket, Monitoring is straightforward. This is most of the monitoring, how it happens. Right? How many invocations did my function get? What is the duration of each run in milliseconds? And how many errors I got? As simple as that. Okay. Now let's consider distributed systems again. I want to know how much time a deep learning task has run. Okay, let's uh, let's scare you a bit more. Here, okay, here we have multiple tasks being run. After data cleaning, there are 100 files which have run through the data cleaning task, and now there are 90 files which have run through the deep learning task. Where the hell did those 10 files go? In which server did those 10 files have lost? Out of the 100 servers, where did the 10 files get lost? Are all the 10 files lost in a single server, or are they, it's like in one server it's 2 files lost, in one server it's 3 files lost? How do you check that? And 100 servers is just a small example. In the production workload there are 833 servers being run, and I want to pinpoint where the 10 files got lost. It's not so fun, right? Serverless. So monitoring is a huge monster when it comes to serverless architecture. It is still an unsolved problem. Even logging. What you can do is the next. Most monitoring system needs a serverless server to be running on, like Grafana, etc. So you have a server now for monitoring a serverless architecture. Really? Like really? You're monitoring a serverless architecture using a server? What about logging? Logging is a bit easier than monitoring. Like for example, after an entire run is completed, ask Ansible to zip all those logs and send to an S3 bucket from all those 100 servers. Name the servers accordingly. Key server 1, server 2, server 3. Have separate buckets for each server. It's fairly straightforward. If possible, use the cloud servers tools itself for monitoring. AWS has launched X-Ray, which helps monitor distributed systems. So some conclusions are serverless computing is super good. Let's do more of that. Especially if your company is a machine learning or deep learning shop, it saves you tons of money and a lot of developer productivity. You don't need to have DevOps guys. Sorry, I'm not talking about unemployment here. So the software engineers can focus on better things rather than sitting and maintaining servers. But it might not be the choice for everyone. So select it properly. Scaling up serverless systems are really difficult, like how I explained you. So scale them up only if you want to scale them up. Don't do hype driven development, right? Everybody using deep learning, let's also use deep learning. No, don't do that. 90% of the companies who use big data tools don't really have big data, trust me. Plan your monitoring very carefully. Just like I've told you, even if a single file gets lost, if it's a healthcare file, then you are in big trouble. And tracing that file is very difficult when it comes to distributed serverless monitoring. Like 800 servers, single file lost. Good luck with that. So thank you for bearing me for so much of time. If you have any doubts, I'd be more than happy. Do you have time for doubts? Not really. Probably 2 minutes.
Okay. So we have time for questions. Yeah, please.
Yeah, please.
I want to make sure you use the Lambda, which is the service function to run the deep learning service, and you run inference, right? And you just mentioned it's like a container, so when you launch another function, you need initial time to launch the container. And in my experience, if you wanna run inference from a deep learning model, it might be cost a lot of time for the first run. Maybe you need to warm up, maybe you need to load model, which costs a lot of time. So I want to ask you, I think the performance will. Yeah, I'm wondering.
Yeah, from in our architecture, it's a batch architecture, right? So uh, it is just milliseconds of difference, or mostly seconds, right? Creating a server container from scratch. For us, we don't care about that because it's a batch architecture, right? Whenever there are files coming, then only do this. But when you are a customer facing company, it really matters a lot. What I can't explain you because it would take a lot of time to explain that, but you can work around it. uh, the containers are not destroyed after it completes the entire run. Lambda does not destroy the container for at least for some time. It is called thatching. Okay. It is just kept warmed up. Within that time, if it gets triggered again, it would take zero latency for it to run. So you have to figure out how to keep it warmed up. Okay.
Hey,
Yeah.
这边有。
I have a question is because in serverless, so you have a lot of function. How do you organize your project? Because it seems like you will have a lot of function, a lot of different files, and how do you manage to have something coherent to work with your
Uh, what we did was we used Docker. Uh, so all these files run on a Docker container inside the workers. Okay. How did I organize my project is simply the data cleaning task runs, stores the file in some folder. The next task would be machine learning, which takes that particular folder as an input folder and stores in an output folder. And the final one is to push files from that output folder to some database. So it's sequential basically.
But I was thinking about the code of your, like, you have a folder and inside you have all the functions.
Okay.
I was thinking about the code base.
Ansible, yeah. Ansible, you can write tasks inside Ansible. Each task, for example, data cleaning is a single task. Inside the task, I'll ask it to run some Python file, which has a cleaning code. Ansible runs all of them sequentially, and the file names, the file formats, etc., are depending. It depends on the software design. So the better software designer you are, the better. It comes with experience. That's what.
Hi. You have told us many of the difficulties and limitation of serverless architecture. So my question is, have you ever faced a scenario that you have to give up serverless architecture finally?
But the fact that we have a serverless entire serverless system running perfectly now. Till now, thankfully, no. We have completed making it self-healing also. We have completed the monitoring. It's not as easy as I'm just telling you, but whatever we wanted to do, self-healing, serverless, stateless, etc., we have completed it. Probably in the future, maybe. Probably I'll tweet to you if I give up serverless, but till now, no.
When you talk about distributed systems, you mentioned self-healing, and I'd like to know, is there any example where a serverless architecture that is not self-healing, and what the biggest problem of it?
Disadvantages of self-healing,
Uh,
disadvantages of not having self-healing. Like I told you, self-healing, for example, if a single worker goes down, uh, I should not be losing the files which are inside the worker. Disadvantage of not having self-healing is that those files are gone forever. You will know what files are there, but they're lost.
Okay. Any other questions? Okay, please.
I want to continue the previous one's question. Even you have self healing for example, to secure your intermediate data, but it's that give any help to your machine learning case, since it sounds your deep learning case is one I don't know how to say, one time task, and you must complete the whole execution, and then you get the result. Yes, but when some of the worker down, or some of the worker time out, even you get the intermediate data, what can you do with the data? Can you also have a correct result of your simulation, or yeah?
For example, let's assume that one of my worker is down. So I have 100 files remaining. I have two queues. One queue is where the workers take input from. The other queue has files which have been left out because the worker is down. So 100 files are in that queue, the processing queue or whatever. After the entire run is completed, I will have another lambda which will check the size of the queue. If it is greater than 0, push the files from this queue to that queue and run the workload again. Now there are 100 files, single worker, entire run is completed.
OK，时间的关系，我们这一场就到这边结束哈。那我们再次谢谢我们今天的讲者。Thank you.